5. Is it better now? Hopefully. All right, let me check. Let me check. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Mm-hmm. 1, 2, 3. 1, 2, 3. 1, 2, 3. Everything is named. All my streams are named Chillin. All the streams are the same name. 1, 2, 3, 4, 5. This is the previous stream. That's not it. We don't want that. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3. One person. I don't know. I must have shut it down. I must have shut down StreamYard, and it messed everything up. Let me check that everything is well, fine, and let me hear 1, 2, 3, 4, 5. 1, 2. Yeah, it's good. It is. It is good. All right. Oh, it's this. Let me put this here. Oh, I gotta close some windows. Let's close some windows. We're done with this. This. Let's forget about these papers for now. We'll come back to the papers. ChatGPT X. Let's see what's going on with X. The new Senate Majority Leader must respond to the will of the people. What's that all about? I don't know. From impossible to late. It's basic. We specialize in confronting things from impossible to late.
Yeah, I mean, this is pretty crazy. I mean, it's a custom-built tower with arms that are designed to catch the largest and heaviest flying object ever made and pluck it out of the air. I mean, that's the theory anyway. So.
Yeah, I think it's funny. People actually forget now that they're actually meant to lift and stack the rocket. The cranes have such bad wind capability. But one time, the booster legs were going to weigh a lot. Elon just said, delete the legs, delete. We're like, well, you just use the arms. And then he said it again. And we go, wow, he's serious. Okay, we better get on this. And now it seems normal.
We think at least seems plausible.
It seems plausible. Yeah.
I mean, it's still super crazy. But the more you talk about it, I mean, I think, at SpaceX, we specialize in converting things from impossible to late. So.
He made so much money the last couple of days. Tesla went up by 30%. Just today, it went up by another 8%. How much? Let me check 1 second. Tesla is up today already by 11%. Jesus Christ. I am making gangbusters. I'm running away with the bank. Yep. Yeah, it's unbelievable. Oh, I'm looking at the wrong account. Let me check my portfolio. How many millions did I make today? 1 second. 1 second. 1 second. Let's see what's going on today and today. And today, Jesus Christ. Jesus. Very nice. But Elon Musk, yeah, is making a lot of money lately. Let me just remove this. All right. It doesn't affect me. I work manual labor. So what do you mean it doesn't affect you? You should be invested. I don't want to give financial advice, so I shouldn't say you should be, but you should listen to, I would say, Warren Buffett. So whatever savings you have should be, anyway. I don't want to give financial advice, but Elon Musk he made a very good betting on Trump. That really worked out for him. He spent a couple of millions, and now he's wealthier by, I don't know, 100 billion or something. How much is he up? Tesla is worth more than $1 trillion as of today or something. History shows we were healthier before these two came along. Yep. I mean, in the beginning, this idiot kept saying that you don't need to wear a mask. You don't need to wear a mask. You don't. And then we saw him wearing two masks. And then he was in the stadium without a mask. I mean, this guy's a complete buffoon. It's like, I mean, he's a professor. He wrote the textbook on schmirology and immunology. Fine. So he wrote a book, but and he's a multimillionaire. He has patents, and anyway. And this idiot literally said on stage that Schmovid is just the seasonal shmoo, shmoo, shflu, shflu. Anyway, a bunch of idiots. Kamala's stepdaughter, wonderful. Trump's granddaughter. Trump has beautiful chicks in the family, unbelievable. Real, okay, who is this? Real GDP per capita, Canada. Elon Musk, truthful, LOL. So this is real GDP per capita. Real means, I guess, purchasing power. What can you actually purchase? Not so it takes into account what we call inflation or anything like that. GDP per capita is actual quality of life. So this is actual quality of life. 1995 is 100. So we're starting at 1995. All right. So 2020, why did it dip? I guess something happened here. I don't know what happened. And then this is going up and this is going down. And this is Trudeau took office November 4th, 2015. Oh, yeah. Yeah, basically. So Canada was tracking the US. The Canadian economy was doing fairly well. And then Trudeau, Mr. Blackface, you see that his policy at the end of the day, yeah, not good. Right now, Canadians are well, just as well as Americans and Canadians were in 2015. So their quality of life has not changed, whereas the American quality of life has risen. And by quality of life, we mean we have more cars. Yeah, he's Fidel Castro's son or something. That's what they say. Yeah, he actually hates, people with melatonin in their skin. He hates them. He really hates them, apparently. Anyway, I was gonna look at runway models, or let's look at the bikini. Let's look at bikini. Uh, it's difficult to tell what's going on. The cameraman, he needs to show the whole body. It's useless to see just this part. I need to see everything. Plus, I need to see them walking. This is useless when she does that. I need to see her walking forwards and backwards. And slow motion is better than not slow motion. Let's skip the nudity because, of course, if I show nudity, they're gonna remove my video. Look up Marissa Dubois. Marissa Dubois. Marissa Dubois. 1 second. Marissa Dubois. Whatever. The boat. Dubois. Uh, no thigh gap. I need to know how tall she is. Yeah, she's pretty good, not bad. No complaints. She's okay-ish, okay-ish. The tummy is flat. That's critical, obviously. I need to see where the nipples are. The location of the nipples is critical for me. Yeah, she's nice. All right, let's get back to it's frustrating when they don't show the behind. Well, I could look at the whole video. Would you hit it? Uh, Probably yes. But when you're with a chick, I need to taste her, and that's really what I would say the most important thing is the way she tastes. But yeah, sure. I mean, probably would. The question is, would I want to stay with her, for more than once? Once, you could be with a chick once, twice, but the question is she perfect? And perfection has to do with taste, with smell, with body odor. So I'm really sensitive to body odor. Probably, dude, how high are your standards? My standards are just mine. It's like my personal preference. Like I don't like I I could have a chick that is, not the most beautiful, not the most everything, but if she tastes good, then that's critical. And of course, if she likes BDSM, then it's really important. If she's controlling, that's a plus. You know what I like. I mean, I don't like submissive chicks. I hate like if she's submissive, that's a complete turnoff. I don't want to be with her. I lost my standards after 30. No, don't do that. Don't. There's no reason to lose your standards. There's no reason. So when you go anywhere and you see literally the hottest chick around, just walk up to her and say hi, and how are you? Uh, like I have my lines which have to do, with me being a slave, and I look for BDSM, so I say like my stuff. But you should come up with your stuff, how you introduce yourself, and always walk up to the most beautiful chick and introduce yourself. Like you should have the highest standards. Um, you see, she is not pretty. Uh, Not completely. I'm not totally not pretty, but you see, there's no thigh gap. Terrible. Absolutely terrible. What else we got? Yeah, pretty bad. You see, it's pretty bad. Pretty bad. Really, really unfortunate for her. She's really not pretty. I'm sorry. Like face is beautiful, upper body's nice, but this area is this is a complete disaster. I cannot understand how they have her on stage. This is Yeah, the same goes for her. Yeah, these are I don't understand what's going on. This is baffling to me. Um, yeah, baffling. Pretty good. See, she has no thigh gap, but she has like good ratio, good thighs. I need good thighs. Thighs are critical. So what I discovered is that most runway models are actually not pretty. It's difficult to find a pretty runway model. Yeah, when she's standing, that's useless. I'm getting no information from that. Mm, uh, I need good thighs too. Yeah, you need good thighs too. Yeah, thighs are critical for me. Critically acclaimed thighs. Okay, that's pretty good. That's goodish. Mm-hmm. Pretty good. Not bad. That's that's pretty amazing. That's pretty amazing. You see, the thigh gap is critical. Once there is a thigh gap, that's everything. If there is a thigh gap, that means that the hips are wide and the tummy is flat. These things usually, and you see, she even has a perfect tushy, so she's pretty good. Let's see this. Okay-ish. Okay-ish. Let's see this. Um, Japanese chick with a good body. It's rare. Let's look for. I mean, I think Asians is the same problem all around. Japanese models. Let's give it a shot. Uh, Nothing plays automatically. Nothing is playing automatically. I don't know why. There's no. This is Chinese. So let's see. The cameraman is an idiot because, again, he needs to show everything from top to bottom all at once. This is pointless. This is a complete waste of my time. And now he's moving too far. So she doesn't have a good tushy. Chinese chicks have many problems. Um, oh my God, it's what is this? That she has no tushy, very bad. Tummy's protruding. She's actually okay-ish. Yeah, they have weird bodies. I don't think they exercise. She actually has a good body, a goodish. She's okay-ish. Pretty good. Pretty good. Kind of perfect. The cameraman needs to be. The camera needs to go to sleep. What is he doing? Yeah, she's not so good. Not so good. Yeah, unfortunately. Oh, this is a bikini competition. Um, let's see. Difficult to tell because they're not walking back and forth. They're just standing, and it's difficult to tell. Very difficult to tell just from standing. They need to walk a lot, so you need the whole runway to really check them out and decide. All right, let's see this. This is 7 years ago. Also, you can tell through the years they change. Like, it used to be maybe more acceptable to have more of a tummy, less thighs. Like, it changes all the time. I don't know. Let's see this. Miranda Kerr? No. Um, is this going anywhere? Yeah. Nothing is happening. So she's supposed to be really beautiful. Yeah, she's kind of perfect. That's kind of perfect. That's kind of perfect. The thigh, she could use a little bit more of a thigh gap. Her face is a little bit elongated. Um, but she's okay. She could use some exercise. She's a little bit overly flabby. I need more musculature. You see, there is a thigh gap. She could use more of a thigh gap. But I think she's the most beautiful there is from the runway models. She should gain some weight? No, I don't think she should. Her weight is fine. She should just do more exercise. This chick, um, the the waist the, is not thin. She doesn't have a thin waist. She has a wide waist. A lot of European women have this issue, wide waist. Yeah, she's okay. I mean, obviously they're beautiful. I'm not gonna. I'm just saying, are they perfect or are they imperfect? And by the way, until you see a chick fully nude, you don't know if she's perfect because a lot of it is in the actual shape of her um VJJ. Like like we're not used to judging chicks by by the beauty of their VJJ. But when you see them nude, every VJJ looks different, and VJJs, there's perfect VJJs and there is imperfect VJJs, and VJJs could be in the front, they could be at the bottom, they could be towards the back. They there's different shapes, but we're not allowed to judge chicks by their VJJs, and the same goes for the boobies. It's difficult to judge because it's just difficult to judge, unfortunately. Um, yeah, it, it's easy to look good if you're not moving, if you're not walking back and forth. So a chick could look good uh, when she's not walking. She could look better than other chicks, but then when she walks, you realize she's not beautiful. The same goes for this. I mean, chicks can look beautiful doing all different things, but then when you see them walking, you realize, oh, she's actually not beautiful. Anyway, so there's a lot to be said. I mean, this is basically a whole science, and unfortunately, no one actually, no one studies this. I don't think you can go to any department in the university and study this, but this is something that somebody needs to study this. I mean, there's so much to be said about women. Um, I know. Let me see what you're saying over there. So you're saying I know it depends how her behind folds while she. I mean, there's many parameters. It's a whole science. You can yeah, you can go as deep as you want. Sometimes the boobies are they look beautiful in a dress, but then when she takes off the dress, the boobies are no longer beautiful. So you know it's very difficult to judge. And sometimes they know how to walk, but they're not really beautiful. They just know how to fake looking beautiful. So you got to be able to see through fake. That's we're not allowed to show nudity. Um, yeah, I don't think she's going to be walking, so that's useless. And the problem with Instagram and stuff like that is that they don't walk back and forth. It's difficult to tell. Yeah, it's very and this camera and they don't teach the cameraman how to properly shoot. This is useless. This is useless. What he's doing. She could be beautiful. She might not be. Difficult to tell. Mm, one if you go to the beach, maybe that's the best place to pick up chicks because then you get the most information. But there is chicks like in Russia dipping in frozen water. What are you saying? Cameraman is just following instructions. Same goes for female. I don't think so. I think the cameramen are independent. Um, so this is an interesting way to maybe pick up chicks is to go to these places where they dip. Like I think they're like Christians or something. Who knows? And then you get a chance because they're walking back and forth, and then you can tell. But then they're extremely religious. I don't know. There is a pattern. Wait, what are you saying? There is a pattern on some videos. What do you mean pattern? Um, yeah, and mm-hmm, mm-hmm. All right. Anyway, I think we've said enough about that. Okay. All right. Um, when she turns around, they stop filming. I think that they want you to go to their OnlyFans or something. I think they sell content. I don't know. But yeah, they show a little bit and then they stop filming. Show a little bit, stop filming. So that's useless. The cosmic microwave background. Kiki kiko koko. Bingo. Yeah. What do we got here?
Hello and namaste. I'm doing this video with a sense of awe and excitement, and I hope you will share this feeling with me at the end of this video. The 2022 Nobel Prize for Physics has been awarded to physicists who have proven that the universe is not real. Yes, you heard me right. The universe is not real. What is amazing is that this is just what Vedanta has been proclaiming for millennia. This Nobel
This is woo woo. This is literally woo woo. This is the end of civilization. The Nobel Prize of 2022, I think, will go down as the beginning of the end of civilization. Absolute, absolute nonsense. Literal nonsense. The universe is not real. Where quantum physics meets vendetta. I don't even know what vendetta is, but this is the end. This is terrible. Absolutely terrible.
But we are going to discuss it here today.
As John says, this is absolutely atrocious. Bell's inequality, the weirdest theorem in the world. Absolutely atrocious.
And show why the experiments that were built off of John Bell's original theorem are so important. So we have to go back a little bit in history in order to set the stage and the context of why this is so important. So in the 60s,
so she looks hot, obviously. That goes without saying.
John Stuart Bell was reading the EPR paper, which was a paper written by Einstein and some of his colleagues explaining how they believed that quantum mechanics was an incomplete theory. Now, in quantum mechanics, we say there exists this thing called the wave function, which describes all of the properties of your quantum system, and upon measurement, it collapses into a single quantity that was only described probabilistically before you measured it. Anyway, in the paper, Einstein said that quantum mechanics must be an incomplete theory because this could not be possible. This would necessitate things that he could not believe to be true. And so we were either missing something in the theory. Somehow these particles were interacting in a way that we didn't actually understand or didn't have a description for yet, but basically it was not finished. And sometime later, John Stuart Bell was reading.
Okay, so she said basically, yeah? You heard her say basically.
Particles were interacting in a way that we didn't actually understand or didn't have a description for yet, but basically it was not finished. And sometime later.
What does that mean? I honestly don't know what she's talking about. So she's describing the EPR paper. E stands for Einstein. So this is Einstein's paper that he wrote that he said something like quantum mechanics is incomplete. I don't know what he meant. I never read the paper. I tried reading at the beginning and I didn't really understand it. So I don't know what Einstein meant by quantum mechanics is incomplete. My feeling is maybe because I think it's possible to explain, I think, meaning I think this is what Einstein meant when he said quantum mechanics is incomplete. So I think what he meant is the following. Now, I don't think about quantum mechanics. I have about Bell's theorem, I have my absolute understanding. I'm not uncertain about Bell's theorem that it's incorrect. Bell's theorem, Bell's inequality is incorrect. So Bell's inequality says that when two particles are entangled, let's say they're created from one parent particle. From one parent, a parent particle decayed into two particles. The parent had no spin. The two daughter particles have opposite spins. In this case, we say they are entangled. The two daughter particles are entangled because they have opposite spins. That's it. So they have some commonality. Two quantum particles that have a common something, we say they are entangled. Okay. So Bell said that when we measure them each separately, we always get opposite spins in the measurement. And that's surprising. I'm not going to go into the whole explanation again because I've done it many times. But Bell said that the correlation in the measurement cannot be explained by a hidden variable. There's no way to explain the correlation by a hidden variable because in reality we have 100% correlation when we look at the data, but hidden variables cannot give us equal strength as the data suggests. The data is stronger than a hidden variable would suggest. So the inequality, as I understand it, is the strength of the correlation in the data is stronger than a hidden variable can give us. To which I say, absolute nonsense. I can give you 100% strength correlation using a hidden variable. And I've actually done it. I can bring it up for the millionth time. This is one. I don't want to bring up the wrong one. Where is it? Oh, is this the one? This is one. Okay, that's good. My drive collab. Yeah. I think this one. Yeah. This is here. I'm going to give you 100% correlation. So they spin in opposite directions, and I'm going to measure them in the same direction. I'm waiting for it to complete. So let's try to predict it. So we create them with opposite spins, but we measure in the same direction. We're measuring both of them to be up, but one of them we know is up and one is down. So what do we expect? Up, up, or up, down? It's difficult to tell. So the left one, let's say, is up. The left one is always going to be up. I think this one should be down. Up, down is my guess. Yeah, okay. So they're all up, down. Oh, there's also a possibility of down, up, really? The left could be down. Particle A can be down. Yeah, because we're creating them randomly. So the spin of A and the spin of A is a random number between 0 and 360. So A could sometimes be up and sometimes be down. All right. But when particle 1 is up, then particle 2 is always down. And when 1 is down, particle 2 is up. How could this be? How can it be? This is, right? There's no exception. How could it be? So the way I did it is because they share a hidden variable. The two particles upon creation share a hidden variable. And using the hidden variable, I give you, ladies and gentlemen, 100% correlation. So Bell's inequality is definitely incorrect because I have 100% correlation. The strength of the correlation is as strong as can be. There's no stronger than 100%, right? As far as I know, how strong are you? I am, my strength is 100%. No, that's not enough. You need more strength. What does that mean? The strength of the correlation cannot be more than 100%. So you cannot complain that it's not that you have a stronger correlation. You cannot complain that there is an inequality of correlation between spooky action at a distance and a hidden variable. They're of the same strength. So Bell's inequality is incorrect.
Here, John Stuart Bell was reading this paper, and he sat down and he wrote what is come to be known as Bell's theorem in just a few lines of algebra. He showed that if you only assume two things, those things being local realism, locality, meaning you can't travel faster than the speed of light, and realism, which means that things have definite values whether or not you measure them. So for instance, we always say if a tree falls in the forest and no one is around to hear it, does it make a noise? If the answer is yes, this would be an example of definite realism. So he assumed only those two things in his mathematical derivation, and he was able to show.
So did I. I assume locality and realism, and I give you 100% correlation with a hidden variable.
That there are certain quantities that you can measure that are bounded by classical physics. If
That's incorrect.
you assume only local realism. And essentially,
that's incorrect.
He was able to show, on paper at least, that quantum mechanics was incompatible with any classical
That's incorrect.
theory. So anything that was basically including local realism could not possibly work with quantum mechanics.
That's incorrect.
So now, a few years later,
I mean, you're pretty, but that's incorrect.
John Clauser came along, and he was reading.
And this is Kiskit.
Bell's theorem, and he thought that this should be something that was able to be done experimentally. So he was able to actually perform.
There's nothing to be done experimentally. This is nonsense. This is a complete waste of everyone's time.
An example in the laboratory for the first time, a violation of this equality, and show that indeed nature behaves as weirdly as predicted.
Can you actually submit your papers to someone to scrutinize them? So you can watch a video from a couple of hours ago. So I was streaming and I have a friend. His name is Tapioca Weasel. Tapioca Weasel came. Let me find the video. And in a very nice way, we debated, and I presented to him my papers, and he didn't have any defense for the mainstream. Let me see, where's my video? How can I find my videos? I think I have to go to the studio, my studio. And content live, and there it is, discussion. It's a 47-minute discussion with Tapioca Weasel, And I told him, let's publish the paper together. And he said, no, you have to show me that you've done the work. That I don't know. I don't know what he wants. So I don't know what he wants.
All right. So this is the one, I think I showed it already. Maybe I didn't show it to you, but this is the other one. This is the more important one. So this is so I actually added a hidden variable. This is I'm 100% correlated. I can reproduce any experiment without telepathy.
So you're saying, I mean, someone with credibility. So Tapioca Weasel is a PhD researcher in Stanford. He is the real deal. He is an atomic physicist. He is, you know, as credible as anyone can be, as far as I'm concerned. 100%, and a really nice guy on top of it. And so I offered him, let's write it together. Let's publish it together. The paper is ready. The paper is ready. Where's the paper? The paper. This is, I think it's this one. It's a very short paper. Software simulation proof, quantum entanglement using nothing but Einstein's hidden variables, reproduces the predicted coincidences of Bohr's quantum mechanics, whatever. In a video produced by Fermilab. Is this? Yeah, this is the one. I mean, I'm attacking the Fermilab production, but it's the Fermilab video. It doesn't matter what I'm attacking. I'm attacking this video by Professor Don Lemon. Not Don Lemon, Don Lincoln. Anyway, where is it? So, yeah, this is the video.
So this is right. This is up down. It's always up down or down up, because they're 0 degrees apart in the measurement. But anyway, so I'm creating two, and then I'm creating a random particle 1 and particle 2. Share and then I say particle 1, and here is the give it the angle now. So particle A for, I guess. So over 180, whatever, over 2, doing the actual mechanics. There's no telepathy here, so you can't tell me not to.
All right, so I'm just proving that without telepathy, because quantum entanglement means that there is telepathy between two particles that are distant. There's two particles that are distant by kilometers, whatever. So the only way, not only do they have telepathy, but they have telepathy that is instantaneous, that is faster than the speed of light. So we're talking about a violation of the speed of light, of Einstein's relativity, of Einstein's cosmic speed limit. So everybody knows that you cannot violate the speed of light, but Bell's theorem actually says that the speed of light, this is called locality, that locality is violated. So, you know, it's obviously nonsense. You just have to be able to understand why it's nonsense, but obviously it's nonsense. I mean, you cannot violate the laws of nature. So you're saying, I lost my interest for all that after people like Michio Kaku started yapping about abstract nonsense like multiverse. Yeah, these people, I don't know if Michio Kaku talks about the multiverse, but he is very nonsensical. And they are all, yeah. And now they gave a Nobel Prize. In 2022, they gave a Nobel Prize to these three guys that proved Bell's theorem, and Bell's theorem is literal nonsense. I mean, basically, this is the end of civilization. This is the end. This is the end of ends.
To use this is completely meaningless.
Let me just show you his reactions.
And then I want to calculate the randomness, but I want the randomness. I want to increase and decrease the amount of randomness, right? Because when they are, this is allowed. I can do anything I want. So ability. Let's just
notice I'm explaining everything. There's nothing I'm not explaining. I'm not skipping anything.
The cosine squared, but then I'm correcting it relative to the correlate. You cannot tell me that there is right. You cannot tell me about Bell's inequality, but I'm limited by the correlation. I have no limit to my correlation. The two particles are exactly 100% correlated because their spins are correlated, and the measurement, and the randomness is correlated. The randomness is the same, and the spin is 180 degrees off. Or if you want, you can have them both pointing. I'm able to reproduce any experiment you want. 0 degrees, 90 degrees, If we, this is going to take a while because it has to. Did you write? No, I told ChatGPT to write it. I wrote the.
So his question is, did you write this? And I tell him, no, I told ChatGPT to write it. I mean, I don't need to write it. I don't like. I can have a worker write for me code. I can have ChatGPT write for me code, or I could write the code myself. That's irrelevant. I mean, I don't even need the code in order to prove my point. I mean, I can prove my point without code. I mean, my point is so straightforward, but I knew it's going to work. I told ChatGPT, and it's all recorded. It wasn't trial and error. I told ChatGPT, it's all recorded. You can see me when I created this code. I knew exactly what I'm going to tell ChatGPT and exactly what it's going to look like. So it's really straightforward. It's just basically three lines of code. I mean, it's minimal lines of code.
ChatGPT. How does cosine squared come from? I don't care.
So he's asking, how does cosine squared come from mechanics? I'm not disputing it, but since you brought it up, I'm curious. But that's irrelevant. It doesn't matter. We're not discussing cosine squared. We're discussing, is there telepathy that violates the speed of light between particles? I mean, we're talking about two completely different things. He's asking me, why is it cosine squared? But I'm debating whether two particles have instant telepathy across the universe. It's like like it doesn't make any sense. It's like a little baby crying, and I'm trying to run some MRI analysis on its brain. It's like he's asking me why it's cosine squared. I don't care. That's not the point. I could use any calculation as long as I don't have telepathy. That's my whole point.
As long as there's no telepathy, right? We're just trying to disprove spooky action at a distance. I can do any calculation I want, right? We're just trying to eliminate spooky action at a distance, telepathy.
And I don't even think people understand. I don't know what's going on. It's like no one understands. No one understands what needs to be proved, because if you knew really what you need to prove, it's so trivial that there's nothing to do. Nothing here makes sense. The whole thing is so ridiculous.
I'm not disputing it, but since
they gave a Nobel Prize to people who proved that reality is not real. I have no words beyond that. I don't need to say anything else. This is physics. 21st century physics is what? The Nobel Prize 2022 was given to three guys that proved Bell's inequality, namely that reality is not real and locality is not local.
Brought it up. I'm curious. Oh, I think
meaning that two particles commune instantaneously, violating Einstein's speed of light law. Well, I don't know. What else do I need to say?
This is ChatGPT code. This is his code, not mine. So I gave ChatGPT the instructions, and there's a paper that explains it. So that's it. So here we ran it, and level 2 is also up. And if you go for 45 degrees, produce the results for you. I have 100% mind. So then up. I'll tell ChatGPT, you tell me wrong when you have hidden variables relative to quantum 100%. So I don't understand what they're talking about when they say right. Bell's inequality is that there is an inequality of strength of correlation between hidden variables and telepathy. But no, there isn't. No, that's incorrect. That's like absolutely incorrect. I can give you 100% correlation, then there's nothing stronger. So Bell's inequality is incorrect. So if you're relying on Bell to prove some inequality, then that's wrong. And I don't know. I don't understand what experiments these people are doing. Because I mean, whatever experiment, I don't care what experiment they're doing. Whatever the experiment they're doing, tell me the data and I'll reproduce it. Because I have 100% correlation. I can play with it. I don't care. We're just trying to disprove the telepathy part. See, I don't want to talk right now about anything else but telepathy. I don't want to confuse the debate. I don't care what the mechanics is. It doesn't matter.
So he says, well, don't you want some mechanical argument for the math? No, I don't need. I'm not here to argue for the math. The math can be anything. I don't care. I'm just trying to show that there's another way to get 100% correlation between particles that is not instant telepathy. And he doesn't even understand it. This is a PhD physicist, atomic physicist, researcher in Stanford. This is it. You don't get any better. And he keeps talking about something that's honestly, thoroughly Irrelevant.
That's not the point. Fine, then we don't understand the exact forces. I don't care at this point. This is infinitely more important. The telepathy. I'm disproving the telepathy, and I'm done.
I'm disproving the telepathy. And he says, yeah, but well, explain to me the math. I don't care about the math. I disproved the telepathy. I could use any mathematics I want as long as I don't use the assumption of telepathy.
I don't know what else to do. Like,
meaning, if you look at the code, right? This is this is the particle, and the particle, it has, when it's created, it's given a spin and a randomness factor. And then when I tell a particle to measure itself and tell me, well, here's the angle of the measurement apparatus. This is the angle of the magnetic field. So based on your spin and your randomness, are you up or down? And the two particles always know to be opposite each other. How do they know this? Well, because when they were created, I set it up so that when they do the measurement, when I ask each particle to measure itself, they're always going to give me opposite angles. That's the way I set it up. From creation, there's no telepathy here. There's no telepathy. When I'm telling particle to measure itself, I'm not telling it what the other particle measured. It doesn't know what the other particle measured. But somehow, even though it's random, right, there is randomness, but because the randomness is shared between the two particles, they give me correlated results. Their ups and downs are always correlated, however I want them to be correlated. If I want them to be 100% correlated, then they could be both up and down and up, down and whatever correlation I want, I can produce. I have 100% control over the measurement. So Bell's inequality is wrong. I don't care. I don't understand. I don't even understand what he's talking about. It's so ridiculous.
I don't know who to talk to. There's no one to talk to except for you. And I'm spinning in circles because I don't know what else to do. I'm trying. I don't know how much more. What more do I need to prove or disprove the telepathy? What else do I need to do? I mean, I didn't need to do this. I did not need to do it. I didn't need to do it because it's.
I don't even need to write this code. The actual argument is enough. The logic of my argument is enough. You can't argue about anything about you might as well argue that I didn't create this development environment. I didn't build the computer on which I ran this experiment. It doesn't. I don't care that I didn't build this computer. That's irrelevant. I don't even need this code. The argument that I'm arguing should be enough to disqualify Bell's inequality, on which the Nobel Prize is based.
It's obvious. So I don't even understand what these people. I don't even understand what they're talking about. But now that I've done it, what do you want now? It's like I can argue from reason, okay, but here it is. But I mean, it makes perfect sense that there's nothing new to besides you. I mean, do you want to write a paper together? You can be the lead writer. I'll just be the. I don't care if you give me credit. I'm just tired of.
I'm even telling him, I'll give you the paper. You publish it. Don't even mention my name. I don't even need to be mentioned. I don't care.
Entanglement. I don't want to hear that word ever again in my life.
I just don't want to hear the word entanglement ever again in my life. This utter nonsense. Bell's inequality. Such nonsense.
Because I'm not here for the entanglement. I'm here for ether. Actually, I'm neither. So tell me if you want to write the paper together. I mean, let me see. You need to prove you understand the theory because it's not telepathy. That's what you need to prove for me to take you to. I don't know what you mean. I don't know what you mean. Explain. And you aren't even close. I'm sorry. Close to what? Close to what? Explain. I don't know. What do you want me to prove? Tell me what you want me to prove. You need to tell me what you want me to prove. Like, I can prove anything because I have 100% entanglement without telepathy. I've entangled the two particles with a hidden variable. What else do you want me to do? You need to prove you understand the theory. What do you mean? What theory? There's no theory. I know. I need you to demonstrate it.
Anyway, I don't know what he means. I need to prove. I need to show. I need to do. I need. I don't know what these things mean. I don't know what you want. What do you want from me? Tell me what you want. Tell me what I need to do to disprove the 2022 Nobel Prize. Tell me what I need to do to disprove it. You tell me. I don't know how to disprove it beyond that I've disproved it. What else? I that's it. I've done the most. I don't know what else I need to do to disprove it. I've disproved it.
That you can articulate our theories in a way that we agree. Tell me what you want me to do, I'll do it.
I don't know what these words mean. I need you to demonstrate that you can articulate our theories in a way that we agree with. I don't know what that means. I don't know what he means.
Besides that, but tell me what you ask me a question. I don't know what it means. I need you to demonstrate that you can. I told ChatGPT here. Let me show you the instructions I gave ChatGPT because that ready it here and this random value. Each spin will be a number between 0 and 360.
So this is the instructions I gave ChatGPT in order to write the code.
A random value, create two particles with. Yeah, this is it. Here's the prompt. Please write a Python script. Generate a random value, create two particles with random opposite spins and this random value. Each spin will be a number measurement angle needs to return value. The random value should be we get closer to 1.
And of course, there's a video where I developed this prompt. And I knew exactly what I'm going to tell ChatGPT in order to disprove, in order to create this code that disproves the 22 Nobel Prize.
180 degrees with the randomness 0.
The absolute dumbest Nobel Prize I've ever heard of in my life.
Difference 0 and 180 degrees. Notice that measure should not call NP random rand. Rather, measure should use the random value that was passed to the particle at creation. Run this test 1,000 times, plot the results, columns, up, up, down, down. ChatGPT's explanation. If you want to ask ChatGPT why measure looks like that, probability calculation, probability measure up depends on cosine squared of half the angle difference, which is common in entanglement.
So even ChatGPT says, why is it cosine squared, which is common in entanglement experiments? That's what ChatGPT says. I mean, we can look into why exactly it's cosine squared. I don't care. It doesn't matter why it's cosine squared. Why is it important? That's not the point. I can do any calculation as long as I'm not, right? I'm trying to disprove the telepathy. There's no need for telepathy. That's the point.
Experiments. We add whatever the reason they give for cosine squared. I'll take it for now. I don't know what the reason is. I mean, we add a randomness influence that varies with the angle difference peaking at 90 using NP sine 0 and 180. What else do you want me to do? Tell me what else you want me to do. The thing you are disputing. There's no telepathy. I'm able to reproduce 100% entanglement without telepathy.
So you're asking, who actually decides if someone is right or wrong regarding quantum physics? Swedish academia or something. It's like everything else in life. No one decides anything. There's a consensus that evolves. It's Darwinistic, basically. So science, like everything else, evolves Darwinistically. So I can say something and, I can push and push and push and push and maybe slowly, like we've seen other people that have pushed through their lifetime something that after 10, 20, 30, 40, 50, 60, 70, 100 years, everyone switched to their point of view. I was actually listening to Sean Carroll talking about entanglement, and he said in his video on entanglement that no one teaches entanglement anymore, that it basically dropped out of the curriculum from academia, which is basically, that's already evidence that no one believes it. It's obviously wrong. I mean, just that should be enough to convince you that entanglement is nonsense and it's going to go away. If it doesn't go away, then that's terrible, but it should go away. Let me see if I can find Sean Carroll on entanglement. He actually has a chapter on entanglement. Sean Carroll, entanglement. Yeah, a whole chapter in his The Biggest Ideas in the Universe.
Hello, everyone. Welcome to The Biggest Ideas in the Universe. I'm your host, Sean Carroll. And today, well, we're going to talk about a continuation of what happened in the last video. In the last video, our big idea was quantum mechanics. But as I said in that video, I wasn't going to do the whole story. But for one thing, quantum mechanics is too big to have just one video. But for another thing, quantum mechanics very naturally falls into the sort of down and dirty, let's put it to work and use it kind of stuff that is 99% of what business actually worry about. How we teach quantum mechanics in our textbooks to our students, how we put it to use in our everyday life doing calculations, and then the deeper questions about it. And this is roughly the division, not exactly, but roughly the division that I'm using in these two videos. So the previous one, quantum mechanics, was on what you learn in the textbooks, and as a, let's say, second year sophomore physics major. Today, we're going to talk about entanglement. Now, entanglement is, of course, a basic feature of quantum mechanics. You don't need to be fancy or philosophical to get into entanglement.
So he says entanglement is basically is a basic feature of quantum mechanics. Let's hear that again.
physics major. Today, we're going to talk about entanglement. Now, entanglement is, of course, a basic feature of quantum mechanics. You don't need
Oh, come on. Let's try that again.
to, as a, let's say, second year sophomore physics.
Wait, can I? Where can we watch the transcript? Is there a link to the transcript? Oh, there it is. Show transcript. There it is.
Major. Today, we're going to talk about entanglement. Now, entanglement is, of course, a basic feature of quantum mechanics.
Okay. So now entanglement is, of course, a basic feature of quantum. How basic is it? He's going to tell you in a second that no one teaches it anymore. Wait, let me get rid of this line. It's in the way. 1 second. This one.
You don't need to be fancy or philosophical to get into entanglement. It's right there, front and center. And yet, when we teach our students quantum mechanics, we more or less ignore it. In classic Caltech,
We more or less ignore it. So how basic? It's really basic, but we ignore it. That's how basic it is. It's so basic. Let me tell you how basic it is. We ignore it, more or less. Yeah, that's extremely basic, obviously.
a couple years ago, it was the last quarter. Caltech has 3 quarters, 3 terms during the
Listen.
We teach our students quantum mechanics. We more or less ignore it. In classic Caltech a couple years ago, it was the last quarter.
Maybe I should slow down because you can't hear the words perfectly, and every word here is important.
Less ignore it. I taught a class at Caltech a couple years
So I taught a class at Caltech. Caltech, that's like Ivy League or something, right? Whatever.
ago. It was the last quarter. Caltech has 3 quarters, 3 terms during the academic year. So it was the last term of a 3-term sequence on quantum mechanics for 3rd-year undergraduates. And I just did nothing but entanglement because they had basically not been exposed to it. They got like some of the very, very, very basic.
So they weren't even exposed to it. This is 3rd-year physics majors, right? They were not even exposed to it. That's how basic it is. So that's so basic. It's so basic.
But it's a subject within quantum mechanics that is largely ignored, or at least
it's largely ignored because no one believes it. Everyone knows that it's just a matter of time before people will figure out why it's wrong. And I'm here to do that. That's my job, apparently.
Underemphasized.
But basically, you know, who the people teaching physics have already figured out it's wrong. They can't really teach it. It doesn't make sense. It's not really necessary. Nobody needs it. Nobody ever uses it. It's philosophical, but anyway, yeah, it's Darwinistically, it's going away. Darwinistically, entanglement is not surviving.
This is one of the big motivations I have. I think I've told many of you that I'm currently working on an undergraduate quantum textbook myself, because I think that most current quantum textbooks do not take entanglement seriously.
There you go. So most quantum textbooks do not take entanglement seriously enough. Yeah, so most professors, most professionals in physics think it's utter nonsense, think it's nonsensical. It's not even they think, it is nonsensical. It doesn't make any sense. It's literally nonsense. And you know, intuitively, they know it's a waste of time. So right now it's just intuitive, but I've come along and I've taken it, you know, on myself to dispose of this nonsense. That's my job, apparently. You know, that's me. Somebody has a job. Somebody has this job. To me, it's clear as anything can be clear that it's wrong. And so that's it. And I like him in general. I listen to him more than anyone else, especially in the last couple of days. And but when it comes to entanglement, he's completely nonsensical.
Enough. Now, this will lead us very naturally into deep questions in the interpretation of quantum mechanics.
Yeah, and his interpretation of quantum mechanics is the many-world interpretation, which is obviously complete and utter nonsense.
And so it's a sort of very natural umbrella topic. As usual in these videos, I'm using my big idea to talk about many little sub-ideas. So the talk that we're going to have about the foundations of quantum mechanics is here in this video on entanglement. But let me first try to explain where entanglement comes from, because remember, Schrödinger came up with this idea that we talk about quantum systems in terms of a wave function, psi of x.
That's absolutely incorrect. We don't talk about quantum systems. We talk about the electron in an orbit around the nucleus in an atom that is waving, and it's described by Schrodinger's wave equation. It's nothing to do with quantum systems, absolutely nothing to do with quantum systems. Now, other people have adopted Schrodinger's wave equation to quantum systems, but as far as I know, Schrodinger hated this extension. So this is incorrect as far as I know.
X and t, the wave function. And you might very well think, well, what is the difference really, or why is there any difference between Schrodinger's wave function and an ordinary classical field, right? If you have electromagnetism, you have the electric field, which is a function of x and t. You have the magnetic field, which is a function of x and t. So it looks to me like the wave function is a similar kind of beast. It's something that takes on a value at every point in space-time. Let me erase this.
And that's actually Schrodinger's interpretation.
So the difference is that this particular version of the wave function of the quantum state looks like a field, but only because it's only applicable to when there's one particle. So this is the wave function of one particle at a time. As soon as your...
It's not even correct to call it a particle. It's a wave function. It describes a wave. It describes the electron as a wave. If you assume the electron is a wave, and that this is literally Schrodinger's own words. Schrodinger said that his wave function or wave equation describes the electron, the electricity of the electron, where it's dense, where it's denser, and where it's less dense. It's literally the electron as a wave. It's not a particle. This is a complete misinterpretation of Schrodinger's wave equation.
Quantum system becomes any more complicated than one particle.
I mean, for him to call it a particle when he's talking about a wave, you already see this is nonsense. This is already nonsense. You don't need me. You don't need anyone. This makes no sense. This already makes no sense. You don't need me to add anything. This is nonsensical. You cannot have a wave function describing a particle. That doesn't make any sense.
Particle, the quantum state no longer looks like a field. And the reason why is because of entanglement. And we don't need to go in order here, so let me skip ahead to the answer. The answer is that when you have multiple particles or multiple degrees of freedom more generally, you don't have a wave for each one of them. There's only one wave that depends on the whole thing. You have the wave function of the universe.
And this is complete nonsense. The wave function of the universe.
I believe that the idea of the wave function of the universe was first coined by none other than Hugh Everett, who was...
Yeah, it's from Hugh Everett. Nothing to do with Schrodinger. Okay, this is a complete waste of time. I mean, I'm baffled. I'm baffled. I don't know how to... I don't know how to deal with this. This is so baffling. So baffling. Anyway. Where were we? We were listening to me talking to Tapioca Weasel.
That's it. There's not.
So I wanted to... Let's look at the conversation I was having with him. So he said, "Did you write this? How does cosine squared come from mechanics? I'm not disputing it, but since you brought it up, I'm curious. Well, don't you want a mechanical argument for the math? You need to prove you understand the theory because it is not telepathy. That's what you need to prove for me to take you seriously." So he needs me to prove that it's not telepathy. He believes it is telepathy. He absolutely does. He's taking a course right now with Sean Carroll, I think. He's reading he's been assigned the textbook, Sean Carroll's textbook. And he actually subscribes. Tapioca Weasel believes in the many worlds interpretation of quantum mechanics.
Nothing else.
And you aren't even close. I'm sorry. What do you mean I'm not even close? I'm done. I'm way past done. I've done everything times a multiple to disprove the 22 Nobel Prize. I know I need you to demonstrate that you can articulate our theories in a way that we agree with. I don't even know what he means by that. I mean, I don't disagree. I'm not disagreeing with anything. I mean, ChatGPT literally says This is ChatGPT's explanation. ChatGPT says the probability of measuring up depends on cosine squared of half the angle difference, NP cosine NP radians delta angle divided by 2 squared, which is common in entanglement experiments. So ChatGPT, right? So ChatGPT doesn't disagree with everyone, with the consent. I'm not disagreeing with anyone on anything. The cosine squared is what everyone does. So I don't need to explain the cosine squared. He wants me to explain the cosine squared. I don't need to explain the cosine squared. Everybody agrees. That's how you do it. You use the cosine squared. Why do you do it? I don't know. Why do you do F equals ma? Why do you do E equals mc squared? You want me to derive everything? Why do I need to derive everything? What's the point with that? That's a given, right? I can reference. It's a paper. I'm allowed to reference in a paper. It's common to reference other papers. I can reference other papers that have done cosine squared. I'm not the first one to do cosine squared. That's what I want. I want you to understand the models you are disputing. I'm not disputing the cosine squared.
They say Bell's inequality is the inequality of the strength of the correlation between a hidden variable and telepathy. That's the inequality. So I say that's incorrect. Bell's inequality is incorrect. It's equal. That's it. And here's the proof. It's equal. There's no inequality. Bell's inequality is incorrect. There's no inequality. Well, I don't know what else to say. Why would you say that their entanglement is less strong through a hidden variable? Here's the hidden variable. This is the most important in this case hidden variable. This randomness. This is the hidden variable. So why would that be less strong than telepathy? This reproduces telepathy. This is the telepathy, right? Because you're saying that in real time, right? The claim is Bell's claim is that in real time they can't be flipping a coin in real time because they must be flipping the same coin in real time to get the measurement, a correlated measurement. So all I did is I just said no.
And I'm explaining exactly how it works. I mean, I'm able to produce the same effect as could be happening through telepathy without telepathy. I'm getting the same effect, right? The whole effect is that both particles, when measured at the same time, they give correlated measurements. How is that possible unless they are communicating instantaneously? They're communicating as I am measuring both of them. So I'm saying, no, I actually don't need that because they're not flipping a coin of how to be measured at the time of being measured. Rather, they were given the result of the flip of the coin upon creation. I flipped the coin upon creation. This is the flipping of the coin, right? This is the creation of the two particles. First, I flipped a coin, random value between 0 and 1. First, I flipped a coin. And then I gave both particles this random value. I handed both of them the random value. So now this is the hidden variable that they share. So in real time, when they are measured, when I tell them, measure yourself, they already have the answer to the flipping of the coin of how to be measured. And that's how their measurements are entangled through the random value. The random value correlates them, entangles them. So they don't need to talk to each other during the measurement. There's no need for them. There's no information being shared between them. Result A is not being given to particle B, and result B is not given to particle A. They don't need it because they both decide how to be measured based on the random and the spin. I mean, based on both. But their spins are obviously already correlated. The spin B is spin A plus 180. So the spins are correlated and the randomness is shared, and there you go. So I don't, that's it. I'm done. I don't know what else to say. This is such a waste of time.
Oh, they can flip a shared coin at creation and carry the shared coin flip reason. I don't see, and that's a hidden variable, and we're done. I don't need telepathy. Why do I need telepathy if I can extend variable? This is the shared hidden variables. I get creation. So why do I need to not violate the laws of nature? I mean, they're claiming that when the two entangled particles are created, and don't randomize measure. Measure should not call any randomness. Use the random value that was passed to the particle at creation. That's the trick. The trick is to force.
That's the trick. The trick is that they share the randomness. They both particles upon creation share the answer to the flipping of the coin of the measurement. So upon creation, the two particles have already pre-conspired to give correlated results when measured. So it looks like they're communing when they're being measured. But that's just what it's looking. It's just a magic trick. It's a simple magic trick.
Is to force ChatGPT to write code that doesn't randomize measure. So you randomize whatever you want to randomize, you randomize.
And I told ChatGPT, just make sure that the call to measure itself doesn't invoke any randomness, except for the randomness value that was assigned to the particle. Like, don't randomize the measurement, except for use the randomness value that you were given, that the particle was given. So it's pseudo-random. It looks random, but it's random that is correlated between the particles. The reason is literally the thing you are disputing. I don't know what he's talking about.
During creation. Anyway, tell me what you want, because as far as I'm concerned, I'm done. I don't know what else to do. I'm like, I'm chasing my tail at this point. I'm watching anyone's video, trying to understand what maybe
I was watching this video by Physics Girl. I think she's the one that's bedridden. Poor chick. Oh my god, I want to cry every time I think about her. Is that her, Physics Girl? Let's check up on her. Oh my god. Physics Girl. Physics Girl. Yeah. Let's see what's going on. Yeah, I watched this. The last time was 10 months ago. Yeah. 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 I don't think she's getting better. Okay. So I was watching her video explaining again, I think, the 22 Nobel Prize.
misunderstood something. Maybe, I don't know. I mean, I'm watching anyone and everyone's explanation of Bell's theorem, and everyone basically says the same thing, and to me, it's nonsense. So I don't know what to do. So I wish you would tell me what data, right? You need to tell me what data use the data without the whole word Bell's inequality. The inequality is from. I don't understand why could it not have happened. I want you to reproduce the work that physicists did to understand physics, the math, the classes, the practice. I don't know what that means. You need to show me the data. Show me the data that you want me to reproduce. I don't know what it means.
I mean, this is obviously nonsense. He's asking me for nonsense. He doesn't know how to reject, how to oppose my position. He doesn't have an argument. So this is complete nonsense. What he's saying is complete nonsense.
The work that physicists did to understand. I don't know what that means. I don't know what that means. The math, the classes, the practice. That's what I don't understand. What do you mean? What do you mean? I don't know what you mean. I don't know what you mean. I wish I knew what you mean. What do you want me to reproduce? You need to put in the work. But at this point, there is like hundreds of hours of me
I don't know what he wants. He wants me to take courses. He wants me to get a PhD. I don't know what he wants for my life.
You haven't,
So in order to write a paper, I need to get a PhD. Wonderful.
and you don't even know. I'm that's all I'm doing. I'm doing just quantum. Where's the paper? What's going on? A solo episode by Sean Carroll. So Mond having, but
Yeah,
Bell's
this is
inequality
it.
claims that there is an inequality. Whatever telepathy you have in real time, right? Each one side together in. If you can get the same result of a shared decision, a shared measurement, right? You want to correlate the measurement. Okay, so you're saying, oh, they're conspiring in real time while violating the speed of light. Okay, fine, that's one option. Another option is that the communication, the telepathy, right? Whatever information is there in the telepathy, right? It's all about the measurement. That discussion, that telepathic discussion, what if it took place upon creation? They decided, they conspired not to. There is. I wish everybody was like you. Anyway, yeah. Okay, that was good. That was a good discussion. Tapioca Weasel is the best person in the world, as far as I'm concerned. All right. What else? What else we got? I mean, I don't know. I mean, this is a surprising experiment. This I need to still go back to and understand. But no one, besides them, no one has this experiment and can easily be explained with a shared. I'm going to run to the bathroom. Let me stop. Let me change the name to Weasel Equality. I did this today.
All right.
I guess telepathy. Telepathy. Oh, that's a good
All
name.
right.
All right.
I don't know what.
100%. Save changes. All right.
Oh,
let me go. I'll be
said
right back.
something.
Bye bye for
I
now.
missed it. How did I miss it? So you're saying, wow, I actually understand what you're saying. I'm going to mention this to someone, pretend to be smart. Why wasn't all this on YouTube 15 years ago? All we had was Thunderfoot. Yeah. Yeah. Anyway, let's see what else we got. I'm thinking maybe to try and do shorter videos, because if I do long form and they give me a strike or something, they take down a video, then hours of content are destroyed. So maybe like once we finish a discussion, I should stop the stream and restart it under a different name or something. Yeah, I think in this case we should say that we reviewed runway models. How do you spell reviewed? Reviewed. We reviewed runway models. Discussion with Tapioca. Yeah, thank you. Weasel, and let's mention you, Jelk, Nicholson. What else did we talk? We talked about the 2022 Nobel Prize. So we can remove this. I mean, but specifically, we talked about entanglement. I mean, quantum entanglement. I think that's enough. Okay, let's. I'll cut the stream. Yeah. I'll cut the stream and restart it. So give me a minute.